How long should I go?
40 minutes, 45 minutes, where you feel comfortable.
Okay.
And then, again, as you prefer, if you take questions in the middle, or take questions the end,
Yeah.
whatever's your best flow, whatever you feel is more comfortable.
Okay.
We're going to get going in about 4 or 5 minutes, so everyone we're going to take a few more minutes to let everyone arrive. If you have any questions, feel free to text them or chat on the right side to the audience. Again, if you look on the right, you'll see that as a result of participating today, you get access to one of our, there's about 20 different 5-star courses we have on Udemy. And all we're asking for is a few feedback points from the webinar. Did you like it? What could we have done better? What, et cetera. And then you just select your course and we'll get you access to the course today. So you have lifetime access to the course. Sometimes they're on technical subjects, sometimes they're on business writing and technical writing subjects. I highly recommend them. And again, it was just a little bit of a thank you to everyone to participate today. Okay, everyone, we're going to get going in another minute or so. Again, for those of you who just joined, you can see that there is a thank you for joining and for participating today. It's an interesting cutting-edge topic, and Sebastian is very much of a leader in the field and knows this topic extremely well and deeply, and so we're going to certainly encourage you to ask questions. You're all muted just for purpose of like background noise, etc. But please feel free at any time to text questions or message questions on the right window. In the interest of time, I think we will get going. My name is Paul Siegel. I'm with Starweaver Group, and we're hosting this webinar today. I'll spend about 2 minutes just introducing who we are, what we do, and some of the upcoming webinars that are happening in the next weeks ahead. We are a company that focuses on executive education around the world. We focus on technology, finance in particular. So we do lots of programs for very big institutions. Here are some samples of the clients that we have and we've been working with for years. So we've been in everything from Australia to Singapore to India to Switzerland to the UK, the United States, Canada, Mexico, etc. And we enjoy doing it. We enjoy engaging with clients and helping them understand what their problems are and helping them solve them in an educational format. So hopefully what you see now is a summary of the kind of programs that we offer in these kind of 5 domains. We do them in person, we do them online. We have a library of online courses. I would say that we do not sell to the consumer, but we happily do these programs for professionals around the world. We largely work with large companies and the employees. So if you have an interest and you think what we do is good, please pass the good word along. We'd be happy to work with you and your company. There's some upcoming webinars. This is the one that we're doing today on the 22nd, and then we're going to be doing one on IDLE on the 6th of December, one on the Internet of Things, and then Best Practices IT Framework, and then because of the holidays, we'll take a break. We'll be announcing typically 4 to 5 webinars per month coming up. So as a bonus for participation today, you're going to get access to these courses. Don't write them down. It's not worth your time. You're going to get a link at the end of the program, but also I put a link in the chat box, and I'll put it in there again. So again, they're heavy finance, there's some IT courses. I heavily recommend and suggest the first one, Business and Technical Writing. When you click on the link here, and the one that I'll give you in the right side of the chat box as well, you just go there, fill out the feedback, select your course, and then later today or tomorrow, you will get access to the course. Lifetime access, just click on the link, that's all you have to do. And if you need to contact us, there's some contact information. But with that, I will pass this off to Sebastian, let him take it away from here and talk about all the good things that you're going to about to learn. So Sebastian, I will send this off to you. It may take you a second, but can you hear me now?
Yeah.
Okay, great, Sebastian. You're now the presenter. And again, I will, for everyone, while Sebastian gets set up, for everyone, I will, again, send off the link on the right in the chat box. Anytime, just feel free to fill that out, and we're happy to get you access to these courses.
Thank you, Paul. Can you hear me?
Absolutely. Go ahead.
Okay, and can you see my screen?
You can see your screen, absolutely, as well.
Great. So thanks a lot, Paul, for the introduction. My name is Sebastian Gueskin. I have over 15 years of experience in IT and open source, and it's a pleasure today to talk to you about Docker and Kubernetes, 2 of the hottest technology in IT right now. So a quick intro about myself. I'm a member of the Apache Software Foundation. I used to be the VP of Apache Cloud Stack, which is an infrastructure as a service solution, so basically managing virtual machines in the data center. I'm highly involved with Kubernetes. I'm a member of the Kubernetes incubator. I donated software to the incubator myself, software called Compose. I'm also the author of the O'Reilly Docker Cookbook, and I have my own company here, Skibox. So it's a pleasure to be working with Starweaver on this and talk to you about Docker and Kubernetes. The outline is pretty basic, just 3 main points. First, I'm going to give you an introduction about open source and how it's really changing the world and changing your business. Then we'll look at Docker and Kubernetes. Okay, three basic parts. Depending on time, I'll probably get out of presentation mode and show you some demo. I don't know the background of all the attendees, if you're more executive or more sysadmin or architects, but I think it's important to actually see the technology in action to really get the power that those new tech can bring us. So let's get started with a quick section here first on business and software. So if you get back to 2011, Mark Andreessen published a paper in the Wall Street Journal, and it was called "Software is Eating the World." And definitely, you see it every day. It's transforming IT businesses, but it's transforming any type of business. From every vertical, every industry, software is taking a more important role. And companies who embrace this revolution, who embrace software and building software applications, they're really getting an edge in the business world. So here, that's one of the quotes that he said: "Software companies are poised to take over a large swath of the economy." And we saw that it's better exemplified by the Uberization movement, if you wish, with a new business model. So Uber, is the world's largest taxi company that owns no vehicles. Facebook is the biggest media company that creates no content. Alibaba, the biggest retailer that has no inventory. Airbnb, the biggest hotel that doesn't own any real estate. So something is happening here in business with those big companies that are embracing software and creating new business model to be successful. So the question here is, are you a software company? And if you're not, maybe you should become a software company. And how does software play a role in your business? It becomes very interesting then, because as you start playing with software, using software in your business, you need to innovate. And the question becomes, how do you innovate and offer new services? How do you go faster than your competition? And how can you embrace this new type of business model and become extremely good at it, so that you can become a leader in your own field? Okay, so there are two main trends there of how do you become good at this. The first one is DevOps, a better collaboration between your developer and your operation people. And here in this slide, I'm showing you something which is called the OODA loop: observe, orient, decide, and act. It's a principle that's pushed by Adrian Cockcroft, who used to be the CTO at Netflix, and he just recently joined AWS, Amazon Web Services. And that's his big view on the fact that with software and how you embrace software, you're going to beat the competition. And you beat the competition by going extremely fast around the OODA loop. And that's the differentiating criteria. How fast do you observe, change what you're doing, take decision, and then build a new service, and then repeat, because you need to constantly repeat and constantly go around that loop. So embracing a DevOps mindset, embracing this view of how to iterate on services quickly, that's really groundbreaking and what can set you apart. The second aspect of how you can embrace Uberization and software becoming a key differentiator is open source. GitHub is a site where people share open source code. So you can go to the site and you can browse millions of software written by people all over the world. A lot of them are open source. Some of them are private because GitHub itself has a business model. But there is over 30 million repository of code on GitHub and 12 million users. So that means that almost all the developers of the world are on GitHub. And I think those numbers were just like 2014 or 15. Okay, so it's probably even higher now. And GitHub has seen a huge growth. So sharing software in the open is also a key aspect of this trend. What is open source? Every type of software, from infrastructure as a service, platform, and then SaaS. So really any layer of the stack. And why do you do it? Well, primarily because as you embrace software and you need to go extremely fast around that loop, you need to reduce the cost of writing software. You need to take advantage of what other people have done in the open. So you benefit from other people's innovation and you stay relevant. Okay. At the same time, you also keep your staff. They stay with you. They're excited. They start contributing in the open. They're rewarded by doing such, and you have a strong retention criteria. So, with this introduction that's more about business and the underlying trends beneath it, let's actually look at those two technologies that right now are really kicking the world. The first one is Docker. Okay. And let me escape a second to see here if I'm getting any questions. Or maybe what we'll do is that, Paul, if there are questions in the chat, you can just interrupt me and I'll stop and try to ask the question. If nobody says anything, I'll just keep on going.
I'll monitor it, no problem.
Okay. So let's look at a look at Docker. Docker is two things. First, to remove a little bit of confusion. It's a company, Docker Inc. It's a startup. It builds new products. It has commercial offerings. You can go to their website and see what they offer. And it's also an open source project that you find on GitHub that I mentioned, github.com/Docker. Everything that they do that's available on GitHub is open source. And they do lots of tools, and they have a really big community. Just as a data point, the latest Docker conference in Seattle in June had 4,000 people. So the community around Docker is really booming. So with that out of the way, what is Docker? And I'm taking this slide from this picture from Simon Wardley, who is an expert in IT strategy. And here you see the regular stack with the hardware, the virtual machine, the PaaS, and so on. And when things started, people started arguing that Docker was a platform as a service to create applications. But really it was not. Okay, Docker, in the sense of a container, is really something that is almost replacing the use of virtual machines. Okay, so it's further down the stack. We'll see that this this concept is actually a little bit more blurry because Docker has lots of tools, not just the container engine. So to get this out of the way, is it a VM or not a VM? Well, it's not a VM. Containers have been around for a long time. Sun was a precursor. They had Solaris zones, more than 10 years ago. So it's been around for a long time. But the industry went down the path of virtualization, especially with hardware accelerated virtualization on the chips. So on the left side, you see what you find in the data center most of the time these days with VMware. You have your operating system. You have a hypervisor that allows you to create virtual machines. Those virtual machines are full-blown systems. They have a guest operating system, and your applications run in those guests. On the right side, you have the view from a container standpoint. You don't have an hypervisor anymore. You have a container engine, so Docker, and Docker allows you to run your apps within containers. What happens there is that the kernel is actually shared among all containers. So you're not building a brand new machine, fully isolated guest for every application. That makes a container much more lightweight, faster to start, and easier to port. Okay, that's the big thing. The portability of container is huge, and its lightweightness, if you wish, makes it an amazing tool for developers. So definitely, containers are not VMs. Comparing the two of them and their performance is not really fair because they're really totally different. The motto of Docker is build, ship, and run. And that's where they started. That's why you see in Docker and even in Kubernetes a huge maritime theme. So you have the whale with the container, Kubernetes is an anchor and everything. So what you end up with in a container, you put all the software that you need for your application. And once it's packaged as a container image, you can literally run it everywhere. You can run it on-premise, in your servers. You can run it on your desktop, the developer desktop. You can run it in the cloud, you name it. So you build your container, and then you can ship it just like a real shipping container. And then you run it because you have really strong portability of that application unit, if you wish. And what this is really is a new tool in the arsenal of your developers primarily, and it's something that's going to change the way your system administrators operate applications. That's for me because I'm more of an infrastructure person. That's the huge paradigm shift, is that your IT operators, your system administrators, they're going to start worrying less about the infrastructure, and they're going to start becoming administrator of the apps, operator of the apps, instead of operator of the infrastructure. Okay, so they're going to go up a level. It's going to become much easier to manage your infra, and they're not going to lose their job. They're just going to start working a level higher. But this new tool, going back to my first section, it allows you to go extremely fast around the OODA loop. It just speeds your business innovation. Okay, it allows you to innovate, 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 and then, of course, win. Okay. So that was, containers. But when you look at Docker, Docker has lots of tools. I was mentioning at the beginning. The core tool is the Docker engine, which creates container. But you also have something called Docker Machine. You have Swarm, which is a container orchestrator for the data center. You have Compose, which allows you to define a multi-container application. And then you have a repository, the hub. Okay. So Docker, in itself, is the container engine, allows you to create containers, but then you have all the tools that really build a valuable ecosystem for your developers and admins. 17 minutes, I think we're doing good. Okay, so the Docker engine basics, it originated in a startup called NCLOUD. Little stories that the founder is actually French, Solomon. And originally it was a wrapper on the LXC technology for containers, which has been around for a while. It's an amazing user experience for developers. That's why people have have become totally crazy about Docker. It's like their success, and the reason why it's become so huge is because they've been able to create a really amazing user experience around containers. So it's super easy to use, and there is an apparent speed in doing things. For the more technical people here listening, now it's not based on LXC anymore. It's based on the Docker own library called libcontainer that allows them to manage namespaces, all sorts of namespaces, process namespace, network namespace, file system namespace. So that's how the application is isolated on the host rather than a full guest OS like you have in virtual machine. With containers, everything is in its own Linux namespace. Resource allocation is constrained using C groups. So it's not an hypervisor, and the processes, the containers, they're not meant to be logged into. They're not machines. They're really processes that are running. Okay. The key is that you use them to package an application. I'm a very technical guy. I like hands-on things. I like to scaffold things up. So how do you use Docker? Here is a basic command that you can type on the command line. Docker run busybox is a container image, and then you type a command, and it will just return. I'll show you some more interesting examples if we have time. The big thing for me is really the App Store or the Docker Hub, or what you can also call the Docker Image Registry. Once you've packaged your application, you can share them. You can share them publicly, or you can also write a private registry on-prem for your company. That means that once you have this registry in place, people can push, they can send images there, and then other people in the teams can actually pull those images and run them. So that simple workflow makes it extremely easy for all your IT teams to work on different parts of a service when they build a full application. And by pushing those images, they can benefit from the work of others and stay in step with their latest innovation. Here's the basic workflow with containers, and really looking at the runtime. You have the concept of an image. That's an actual file system that contains your application. When you run a container, it takes that image and it executes the process that's in it, and that's when you have a running container. You can stop it, start it, and so on. You can make modification to it, create an image. The push that you see on the top right, the push-pull, that's sending the image to the registry. And then the big red circle there, the Docker file, that's a file that you can write to define what goes in your image. Okay? So that's typically how you create an image. Your developers, they're going to write a Docker file, which will be in their version control system, and it will be tied to their continuous integration pipeline, so that continuously, as they write new code, they can create new images, new container images for that particular piece of code. So that was the engine. Another tool in there that you will hear about is Compose. And what people realize quickly is that as they build a real distributed application and they start breaking up monolith into more of a microservice system, they're going to have to write a manifest for that complete microservice application. Okay, so that microservice application will be made of multiple containers. And Compose is this way of writing the manifest. On the developer machine, it's extremely easy. It's one binary that you install, and then you write YAML files that you can then, pretty much execute, and you have an application. So here is an example. That's a very basic example. That's a 2-container application. The first, you see, it's WordPress, and then the second one is MySQL. So the WordPress blogging system needs a database, of course, and you run those 2 components in 2 different containers. That's an old example, but you see things like you can pass environmental variable, you define ports that expose the service, you can define a link to MySQL, and you have this image. The image key here relates to the name of an image in the Docker registry. Okay. Compose is changing, is getting better and better. So what you see here is not a perfect example. It's a very toy example. For example, you wouldn't pass passwords directly in there. That's bad. The links, it's something that's changing. It relates to how the networking of container works, and this has changed, quite a bit over the last year. But that gives you an idea. And once you have written this type of compose file, which could be 10, 20 containers, you just bring it up with a single command. And again, here you see the strength of Docker. They're really trying hard to make the developer experience extremely good. Oops. So a single command, Docker compose up, and it reads your compose file and it brings up your application. So you have the engine and you have compose. Another one is machine. Okay, so that's another Docker tool which allows you to basically install Docker wherever you want. So Docker machine ls, you can see all the hosts that run Docker machine. The relevance of machine has disappeared a little bit because now Docker Inc. has developed Docker for Mac and Docker for Windows. So all your developers and ops people, they can easily install Docker on their laptops, and they don't need to use machine. But a year and a half ago, Docker machine was extremely useful. I put here multi-host networking because that's very interesting. That when it started, people got extremely excited, mostly developers, and most developers only work on their single machine on their desktop or laptop. So they really embrace Docker. But what happens when you start running containers in the data center and you need to have containers on different machines talking to each other? So the way the networking of Docker worked using a bridge and basically a NAT, it was causing problems for the containers to reach each other. The techniques that were used were basically overlays, and those techniques are exactly the same techniques that we use with VMs if we wanted to link VMs in a private cloud setup. So here that you see two machines and you see multiple bridges. That's more for the network guys. Each container attaches to a bridge, and then here we see an additional kind of bridge interface that creates an overlay. But this problem got solved, and Docker network appeared, which is called libnetwork. So now you have this also in the Docker project, and that allows you to have good networking between the two. The reason I mention networking is because it's one thing to have the developers happy, but then you need to move to production. And when you move to production, you're talking data center, you're talking clusters of machines, and you need to talk about managing hundreds, thousands, 10,000s, maybe millions of containers like Google. So you're going to need a system to orchestrate all those containers, and those containers are going to need to be able to reach each other over the network. Okay. So Docker a year and a half ago introduced another piece of software called Swarm, and that's the orchestrator of containers. And I have to say that right now in this field, I mean really at the cutting edge of this open source tech, there's tons of work happening about orchestrating containers. Okay, so Swarm is being worked on a lot, and Kubernetes that I'm going to talk about is basically a container orchestrator. Okay. So you go from the laptop to the data center, multiple machines, and you need to manage those containers at scale. In a production environment, you need an orchestrator. So Docker has its own, it's called Swarm. It used to be a basic API proxy, but now it's been rewritten with something called SwarmKit, and you can keep all those terms for your IT architects and solutions architects and so on. But it's basically a peer-to-peer system that gives you load balancing, ingress access, service scaling, master promotion, things like this. And all of it is baked into Swarm. What's interesting now is that they have actually packaged it inside the Docker engine. So when you install Docker, you now have Swarm as well. Okay, so your developers, they can start playing with Swarm. Your ops guys, they can start playing with Swarm directly on their machine before going to production. And what it gives you is this. I mean, that's a very toy view, but basically you have a CLI, Docker CLI, and you can talk to your Swarm head node, and it sends the orchestrate and it schedules the container on different machines. Linking all the containers is an overlay network so that the containers can talk to each other. Okay, so that was Docker. It's 5:30. Let me do a basic demo. I hope I'm not losing anyone. So here I'm on my local machine. Let me try to make that a little bit bigger. Yeah, that should be good. So I have Docker installed. I can say, let me know what containers are running. I have no containers running. I will say Docker images, and it's returning lots of things because I use Docker, so I have lots of images. Okay, all of these are images that are being pulled from the Docker registry or that I've built locally. So let's run the hello world of container has become Nginx. So let's run Nginx. So Docker, that's the command. I want to run a container, run in the background -d, and I want to expose the container network interface. So here, port 80 in the container. I want to expose this on port 1234 on my host. And Nginx is the image that comes from the Docker Hub. So I run this. It gives me a long ID. That's the ID of the container. Now when I do PS, I see that I have one container running. And if I open my browser, and I go to localhost 1234, I see Nginx. Okay, so that's the real basic. That's the it's not even 101, it's 001 of running a container locally. Here, what happened is that it pulled the Nginx image from the Docker Hub, and then it actually started a container with that image, and I'm seeing it here very quickly. So I could also, if you want to see it, one more time, we could do Ghost. It's a micro-blogging platform. So here again, Docker run, background, I expose the ports. I know that Ghost runs on 2368, okay, that's because I do it all the time. So let's open again the browser and let's go to 2368 and I should see Ghost. No, I don't see Ghost. Okay, that's demo. It's running 2368. Maybe it didn't start. Here you go. Okay. I just needed to give it a bit of time to kind of boot for the process to start. So now I have Ghost. And that's what developers love. They need Nginx, they need Redis, they need MySQL. They just pull the image from the hub and one command, boom, they're up and running. Okay, that's the strength of Docker. So now let's talk about Kubernetes. So Docker is great, allows you to create containers, but now you want to go to production. You want your developers to start developing distributed applications that use containers, and you want your ops guys to actually run those apps in production in your big data center. Okay, so you have a choice of, you need to make a choice on who is going to orchestrate those containers. You could go Swarm, or Kubernetes is another solution, and that's definitely the option that I like. Kubernetes has been open sourced in June 2014. It's Greek for helmsman, so captain of the ship, again, going back to that maritime theme. The growth of Kubernetes is just amazing. In a couple months, we should reach 40,000 commits. 40,000 commits in 2.5 years, 2.5 years. It's extremely huge growth. It's one of the top GitHub projects worldwide. And the velocity of development of that project is so high that it's training the capabilities of GitHub. So that tells you a lot. I love Kubernetes because it's based on Google's internal system called Borg. So if you need to, if you want to get out of this with one thought, is that Kubernetes is actually an open source version of Google internal system. Okay, so that means that Gmail, Google Apps, what else do they have? Gmail, Google Apps, YouTube, Google Compute Engine, even all the Google applications, they're managed by Borg. Okay, it's their internal system across geographies in all their data centers. And that system, Borg, manages everything through containers. Okay, so when you go to Gmail, there's actually something running in containers behind it. Okay, what Google decided to do is to rewrite Borg totally open source. So they didn't take Borg code and make it open. They actually started rewriting Borg in the open. Okay, so just Google Borg, Borg container Google, and you'll find this very technical paper that they published. So it's very interesting, and that's also, this picture is also why I love Kubernetes. You have to look at the lineage of all those technologies. So Borg is the system at Google. Mesos, which is another container orchestrator, I mean, it does lots of other things. It's actually a scheduler. But Mesos was inspired by Borg from discussion, between Google engineers and guys at Berkeley Lab. Cloud Foundry from Pivotal is actually inspired by Borg with all the principles of 12-factor applications and so on. Kubernetes, as I mentioned, is a rewrite of Borg. And Omega is another version that they have internally at Google that was developed after Borg. As Google was embracing containers, managing everything with containers, they actually made some development on the Linux kernel, and they are the ones who created C groups. So C groups that are in the Linux kernel that have been at the basis of containers have been created by Google guys who were working on Borg. So C groups gave rise to LXC, that's the part you see on the right, and then that gave rise to Docker, which now is also involved in the Open Container Initiative, where they're trying to create a standard around container runtime, container image, and so on. So if you look at this picture and you look at the papers around it, you'll see that everything kind of converged towards Google technology. So if you are to make a choice for a container orchestrator, might as well use the tech that Google is actually writing right now in the open. Kubernetes is part of the Cloud Native Foundation at the Linux Foundation. It's a new open source foundation that was started maybe, a year ago, I guess. Additional software than Kubernetes are going to be part of this, and definitely you should pay attention to the Cloud Native Computing Foundation. You have lots of members, like Goldman Sachs, for example, is a member of Cloud Native. So it's not only IT vendors, but also users of tech that are part of the Cloud Native that are trying to benefit from this booming ecosystem. There'll be a Kubernetes certification coming out soon from the Cloud Native Foundation. I'm highly involved in this, and hopefully we'll get to work with Starweaver on that. So definitely pay attention to Cloud Native. Kubernetes has lots of partners, services, and also, of course, technologies. So look at them. And lots of users. The latest Kubernetes conference was a month ago now, or not even, early this month in Seattle. And the shocking thing, in a good way, was that there was a ton of user presentation. Okay, guys like Ancestry were talking. The Golf Channel, if you guys like golf, the Golf Channel is actually using Kubernetes underneath. Disney Animation is using Kubernetes. So, look at the Kubernetes website and you'll see the users, the case studies, the videos. It's extremely interesting. And lots of jobs. So, developers and operators, if you guys like, looking for a job, that's a sign of a booming ecosystem and a tech that's really picking up tons of jobs out there. So how does Kubernetes work? As I said, it's an orchestrator of containers. So what you see on the left, you have a master node or a head node. This head node exposes an API. These days, everything exposes an API, and you need to talk to the API. So on your workstation, you have a client called kubecontrol. You talk to the Kubernetes head node through the API, and you tell it, hey, run this container. And the master node has a scheduler running, and it will pick one of your nodes in the data center and place that container on that node and execute it. So on the node itself, you have an agent running. It's called a kubelet. You also have Docker, the Docker engine running, because the container needs to be executed by something. Okay, Kubernetes itself is not a container runtime. And then you have a proxy, which is used to manage networking rules. The state of the cluster is stored in something called etcd. It's a key value store. Very much like Zookeeper, if you know Zookeeper. So if you look at this high-level architecture, there is nothing revolutionary about it. We see the same thing in Mesos. We see the same thing in things like Rancher. It's a little bit different in Swarm, but not that much. They also use etcd. They just use a peer-to-peer system that's changing things a little bit. You can make this setup as complicated as you want because the master can be replicated, can be operated in a HA node. The etcd storage can also be multi-node. And then, of course, you have multiple nodes in the data center. Okay. The one big difference with Kubernetes is that instead of placing individual containers, it has a concept of pod, and a pod is actually made of multiple containers. We cannot go into much details around why pods, but it's an interesting difference with Docker itself. Getting started is extremely quickly. If there are some tech guys, deep tech guys on there on the call, there's a software called Minikube. Grab Minikube from GitHub, do start, and you have a standalone Kubernetes on your machine. And then you start playing with pods, with things called deployment services and so on. I'll try to give you an example. We do a release every 3 months. Version 1.5 is going to come out in December. You can participate and see all the features. It's all open. There's a clear roadmap. There's a very active community, and so on. You can install Kubernetes extremely easily with a tool called kubeadm, and that bootstrap process is very similar to Swarm. If you do Docker Swarm, you'll do Swarm init and Swarm join to be able to build your cluster. The biggest trend with Kubernetes, okay, is that definitely the user experience is going to be improved. That's something we are, definitely learning from Docker. Trying to put emphasis on the user experience, the developer user experience is really important, improving the contributor experience. But technically, there are 3 things that I like here at the bottom. Kubernetes now has cluster federation. That means that you can have a cluster on AWS or on Google Cloud or on Azure Cloud, and then you can have a cluster on-premise, and you can actually migrate workload between those clusters. You could have everything on-prem in different data centers, and you could federate those clusters and migrate your workload. It's not really a true migration, it's more of a load balancing of the workload, but the system self-scales, okay? There is also something called third-party resources, and it's going to be tough to explain here, but third-party resources are a way for you to tell Kubernetes to manage your API for you. So let's say that you want to develop a new API. Instead of writing your own servers and so on, you can actually write that API directly into Kubernetes. It's extremely powerful. And the last bit is compiling to Kubernetes. So that's something that we're probably going to see more in the coming years. It ties a little bit to serverless computing. Okay, that's the idea of writing your code as if it was local, as if it was going to run locally. But when you compile it, it's actually going to split all the various functions and run them in your Kubernetes cluster. So those are some of the big trends that you're going to see out there. So that's almost it. I'll just briefly go through the ecosystem here, because that's one of the reasons why those stacks are extremely powerful, is that there is a booming ecosystem for both of them, and they overlap. Okay, Kubernetes uses Docker. Docker uses some of the Kubernetes technology, and then technologies that work with Docker also work with Kubernetes. So there is lots of overlaps. It's not like the two are enemies. Okay, and lots of tools are coming up. So you have new operating systems to use. Okay. So maybe you're a Red Hat shop, so you may want to look at Atomic. There's CoreOS, Ubuntu Snappy, Photon OS from VMware. VMware recently announced a Kubernetes as a service solution. So if you want Kubernetes in your VMware shop, you can go down the road of Photon. So yeah, you can start embracing new operating systems that are designed to run containers. And that's the only thing that you're going to be able to do on those OS is run containers. On the networking side, you have new overlay code technologies. So Leap Networks, Plano, Calico, WeaveWorks. Okay, and on the monitoring side, definitely monitoring is extremely important. So CAdvisor, sysdig is great. You also have Prometheus that is at the cloud native foundation. So lots of monitoring solutions for this system. Yeah, I still getting throw some time here, but really should give you a demo of Kubernetes. I have Minikube running here, which means I have a Kubernetes instance running, and my client is kubecontrol. So kubecontrol get my nodes, tell me what are the nodes in my cluster, and here I see that I have a single node cluster. It's a dev environment. Okay. Now I can say get pods, and looks like I have some pods running. Those are actually containers, but I can run an app by saying kubecontrol run. And let's run Ghost. Okay, so it's a little bit like Docker. Okay, run Ghost, image Ghost. What this does is create a deployment. And really, we'll have time to give this justice, because with deployments, you now have rolling updates and rollbacks, and you have scaling. It's absolutely mind-boggling. So let's look at our pods. Now we see that we have a Ghost pod running. So that's the container that's running. Let's just scale it, because that's the fun part. Scale deployments Ghost, and we tell how many do you guys want? 10. So let's scale it to 10, and now we do get pod. See, I just scaled my deployment 10 containers automatically, and I can expose that application with a service. But we're gonna try to wrap this up. So what's the end goal with those two technologies that are really revolutionizing IT? It's to develop distributed applications in a microservices mindset. You're going to decompose your monolith or start from scratch if you have a new service, but you're going to write with individual services that you're going to be able to scale, that are going to self-heal, and so on. And you want to deploy those new apps in production extremely fast, so you can rinse and repeat, and you can go around the loop, the OODA loop, extremely fast, innovate, test new ideas, make bug fixes, and then basically win for your business. Okay? So software and IT in general are not an afterthought. You know, it's not anymore the, IT is just running the printers. Now IT is really part of the business innovation. And how fast do you go is really crucial. Okay, you cannot take 6 months to add nodes to your data center, and you cannot take 6 months to deploy a new version of your application in prod. Okay, you need to go extremely fast. And container technologies, whether it's Docker, which gives you the basis with the runtime, or Kubernetes, which gives you the orchestration in the data center, those technologies, they're helping you to gain speed in your innovation cycle. So adopt containers and you'll win on the business side. So thank you very much. Ping me on Twitter, StepGoa, Skipbox, my little startup, and stay tuned with Starweaver, and hopefully we'll do more around Docker and Kubernetes.
Thank you, Sebastian. That was really a very profound and interesting presentation. Personally, I found I'm not the deep technical person that you and the team here listening are, but definitely got into this in a very quick way, brought people up to speed, both from a framework of understanding where the technologies are and the trends, and obviously, I, from a business guy's point of view, can tell you I know when we look to hire and engage people, absolutely right. The people who are the busiest and who have the highest rates seem to be always on the cutting edge technologies, and this certainly falls into that. I wanted to just give it a few more minutes so that if anyone has questions, please text them or chat them on the right. I'm using the wrong terminology, but just chat them on the right. I also just wanted to remind everyone that there is, please do give us feedback. We want to know, was this the right level? Was this the right depth? Was it, what did you like and what we could have done better? And then as a result of that, we thank you for presenting, or participating rather, by getting you access to one of our 5-star free courses. You get lifetime access to the video-based course. You can watch them on your phone, your computer, etc. So do click that link on the right. Hopefully you all see it. And again, this will be available, so if any colleagues are interested in this and they missed this, we're going to be presenting this, making this available online. You just have to log in to let us know who you are, and then you can watch it again. And again, great thanks to Sebastian for a great presentation. I'll wait another few seconds. If there are any questions, please don't feel shy. You can talk about your own environment, etc. If you have any questions and comments. Okay, with that, Sebastian, once again, thank you so much for a great presentation and a great day. Thank you. All have wonderful holidays wherever you may be. We'll be back in touch soon, and come to our website /events to see more upcoming webinars. Have a great day, everyone.